Okay, number 7. A bicycle rider is traveling up a hill. When the rider reaches the top of the hill, she stops to rest. Then she travels down the hill. The diagram shows the rider in the 3 different positions. Guys, remember, if she stopped at the top of the hill, kinetic energy there is 0, and potential energy, that's as high as she gets, so that's going to be the maximum for her potential energy. As she comes down the hill, kinetic energy is going to go up or increase because she's speeding up. Potential energy is going to decrease because she is getting closer to level ground. All right, so which of these correctly describes the potential energy and the kinetic energy of the bicycle rider? Well, when the rider's at the top of the hill, her potential energy is greatest and her kinetic energy is the least. All right, number 11. I'm only going to show you this part so far. An archer shot a 0.06 kilogram arrow at a target. The arrow accelerated at 5,000 meters per second squared to reach a speed of 50 meters per second as it left the bow. During this acceleration, what was the net force on the arrow to the nearest Newton? Well, guys, if you go back and you look at your formula sheet, what do you need to solve for force, which is what you're solving for? Mass times acceleration, okay? You're given 3 numbers, but you don't need all 3. You only need 2, so you've got to pay attention to what you need in that formula. Net force is equal to mass times acceleration. I know that 0.06 is a mass because it says kilograms, and kilograms is a unit of mass. I know 5,000 is the acceleration because it says 5,000 meters per second squared, and meters per second squared is a unit of acceleration. 50 meters per second is a speed, and I know that based on the unit, but it also tells me it is. Okay, so the formula that we need is mass times acceleration. I don't need that 50. They gave it to you just to throw you off. 0.06 times 5,000 is 300. Now, some of you guys have missed some critical items just simply because you don't understand where to put the 300. The whole number 300 has got to be put in and the decimal at the end. So make sure you put it over here. Don't put the 300 over here because then it'll make it look like 0.3, and that's not the same. All right, let's go on to number 29. Number 29. A golfer collected data on the distance a golf cart traveled in a straight line and plotted it on a graph. Which of these does not describe the cart's motion on this graph? The cart moved 24 meters away from the starting point between 2 and 5 seconds. So between 2 and 5 seconds, is the change in distance about 24? And I would say, yeah, it is. The cart moved toward the starting point at a speed of 3 meters per second between 7 and 12 seconds. Well, it starts at about 27 meters away and ends at about 12 meters away. 27 minus 12, that's a difference of 15 meters. And that happened in 5 seconds because from 7 seconds to 12 seconds, that's 5 seconds. So 15 divided by 5 is in fact 3. So yes, the cart was moving back towards the starting point at 3 meters per second between 7 and 12 seconds. So statements A and B are true. C, the cart moved 11 meters toward the starting point between 8 and 10 seconds. Well, here's 8. And if I go over, the distance is about, I'm going to call it 23 maybe. And 10 looks like maybe 17 or 18. Well, 23 minus 17 is only about 6. So did it move 11 meters towards the starting point between 8 and 10 seconds? No, it did not. And then finally, D, the cart moved away from the starting point at a speed of 1 meter per second for 2 seconds. That looks at about 1 meter per second because it looks like in 2 seconds it covered about 2 meters. So that's good. Okay. Just to make sure that you're paying attention, why don't you down here put your formula for slope, y over x, or change in y values divided by change in x values. Because what you did is you did change in y values, your distance, divided by change in time values, which is your x values. Okay, and that bell is just on the screencast. It's not for you guys. All right, the final one on this side. Two forces are applied to a 17 kilogram box as shown. The box is on a smooth surface. Which statement best describes the acceleration of the box? Well, first of all, acceleration, remember, is going to be net force divided by mass. This formula is not given to you on the formula chart. I mean, it sort of is, but it's given to you in this format, and that's not the way you need to use it. Okay, so for this problem, it's got to be net force divided by mass. Your net force, these two are working against each other, so 35 minus 18, your net force is 17 newtons to the right. Your mass is 17 kilograms. So 17 divided by 17 will give you an acceleration of 1 meter per second squared to the right. Okay, so let's go fishing for a good answer. The box accelerates 1 meter per second to the right because the net force is 17 newtons to the right. That sounds good to me. The box accelerates at 1.9 meter per second because the greater force is to the right. I think they forgot to do 35 minus 18. That's not going to be correct. The box accelerates at 3. No. The box does not accelerate because neither force is large enough. No. Okay. You have two forces. Net force is 17. Mass is 17. 17 divided by 17 is 1, guys, and it's to the right, so that's going to be A.